So yeah, thanks so much for joining us, everyone. This is our demo session, kind of soft materials overview. So we're be covering the new soft materials we just announced and released. Josh here from our sales team will take us through the whole workflow. So preform tips, post-processing tips, everything in between. But before we get started, I'll just do a quick little housekeeping here. So throughout the whole session, while Josh is doing his thing, please feel free to drop questions into the Q&A box at the bottom of your Zoom window. I know people are always tempted to throw it in the chat. I'll try to catch those as best I can, but it's much easier for me to keep track of things when it's in that Q&A box, because I can mark when things are answered, and it doesn't scroll as much, so that's really helpful. Yeah, so feel free to do that throughout the session. And then once we get to the end of Josh's talk, then we'll jump into questions. I may also hop in throughout if I see a really particular question about what Josh is up to in that moment. I'll hop in and ask. Lastly, meant to refresh that. Feel free to ignore the bottom link. The top link here, please feel free to join our forums, join the conversation. If we don't happen to get to a question today that you want to get answered, please come to our forums and start a thread. Hopefully someone from Formlabs can jump in to help, but also we've got an amazing 1,000-strong community on that forum who would love to offer advice and see what cool stuff you're working on. So please join us there. We love to have everyone there. And then lastly, I think this is worth mentioning. Josh is going to have some stuff on his screen there that you probably want to blow up as big as you can get it on your screen. So if you look up at the top of your Zoom window, where above me, it's right here. There's a little button that says Speaker View. That'll just make sure that when Josh is speaking, his view will take up the majority of the screen, so you can see what he's working on in the best detail. So. I think that's it for my housekeeping. Yeah, I think that's it. Feel free to take it away, Josh.
All right. Now that Dan's got you all watching me as closely as possible, it's good to meet everyone. My name's Josh. I'm on the sales engineering team, which is sort of a subset of our sales team. Just to sort of give you a quick overview of who I am, what I do, why I'm talking to you. Sales engineering is essentially the applications engineering arm of our sales team. We have a fairly sizable and all in-house sales team that works with customers, people from all sorts of different businesses, walks of life, to help them find 3D printing solutions, implement 3D printing into their workflows, into their businesses. And I sort of assist that team as the sort of engineer on call to jump on a call with customers, print things, try them out for people, see if it makes sense to get printing into someone's business or into their life. So that's who I am. My background used to work for Service Bureau, running metal machines before this, but I've been Formlabs for a few years now, and yeah, spend a lot of time printing, try to print every day. For this session, this is sort of a follow-up to our recent launch of a variety of materials, actually our biggest material launch ever, but within that bundle of lots of medical and dental and all sorts of other materials, we launched the one I'm most excited about, which is this material, Flex ADA, named for that ADA shore durometer, that hardness of the material. That's replacing Flex V2. Some of you folks might have used Flex V2. It's been in our sort of stable of materials for a long, long time. And for a long time, it was our only soft material. So I'm going to walk through workflow with the new material. We're going to talk about what's different. But let's first talk about sort of soft materials within SLA 3D printing, within the world of photopolymers, and sort of what makes them exciting, why I'm excited about it, and why it makes the Form 3 and our other machines a very versatile platform. So, for many, many years, we've gotten the question, do you have a machine that can print silicone? Do you have a machine that can print rubber? Do you have a machine that can print all these sort of buzzwords for soft materials, for elastomers? And the answer is we can't print silicone. You can mold silicone. We've got some great sort of back catalog webinar content about that you can check out. You can do all sorts of hybrid workflows to get a true silicone, but printing in those soft materials is actually pretty difficult. with any technology. And so the constraint when we talk about SLA, or in our case, LFS, 3D printing is, these all have to be photopolymers, right? It's a methacrylate base at the core, and there's some things about the chemistry you just can't compromise on. So to get a chemistry that, prints stably and is able to, work on a machine like this is sort of a big task for materials engineers. So our first one a while ago was Flex V2, or Flex V1, the original. Then we went to Flex V2, which is the one that you probably are most familiar with, that was on the Form 2, that was around for a long, long time, in sort of that charcoal, dark gray, black color. And then we launched Elastic, and I was with the company when Elastic launched, and I remember the excitement because, Flex V2 is a harder material, but the limitation was always that you would run into trouble where it cracked over repeated flexes. The chemistry was really good. It was an exciting soft material within the realm of photopolymers, but it wasn't necessarily all that durable. It didn't stand up to repeated flexing. You couldn't really sort of take it and manhandle it and twist it all around without over time starting to see little tears in the surface. And so we launched Elastic because we wanted to expand to a more silicone-like, a 50A short durometer material that was soft. It was suitable for lots of things like medical modeling, anything really that you'd use silicone for. And then we sort of went back, and with the lessons that we looked at that we learned from that, we looked at our flexible resin, and we thought we can do a lot better here. We can make a material that has that ADA shore hardness and is suitable for those harder rubber applications, sort of, keeping in mind like what a car tire feels like, but that has much more resistance to fatigue, is much stronger, is much more suitable for applications where you're going to be flexing it over and over again, or you're going to be trying to wring it out. And that's really what Flex ADA is taking all those learnings from launching Elastic, taking the things that we saw with Flex V2 and trying to make a flexible resin that maintains that hardness profile that we're not compromising on that with, but is durable, is much easier to print, is easier to post-process, all of that sort of stuff. We'll talk about preform workflows and sort of go into, setting this up. Obviously, flexible materials are more of a challenge than hard materials to print with, and we can talk about why that is. Real quick, before we go into that, Dan, are there any questions in the chat? Is there anything we want to cover before moving on to that?
I think the only thing I can think of is, can you explain what a shore durometer is, what that measurement sort of means?
Yeah, absolutely. So basically, there are multiple scales for hardness. That sort of short A scale is generally used for elastomers for softer materials. So lower is a softer material on that scale. So elastic is a significantly softer material than our flexible material. So you can think of it as sort of elastic is more of a silicone-like, pretty soft, pretty pliable. Elastic is more sort of like a TPU or like a hard rubber, like the sole of a lugged boot or a tire or something like that. I see also we got a question about gluing, and I'll just cover that quickly. You can glue it. If you want that joint to last and you want that joint to flex, you're going to need a flexible adhesive. There are a number of those. I can't think of a brand off the top of my head, but they do exist. I've seen customers do it. In general, all of our materials are pretty responsive to a variety of adhesives as long as they're not alcohol-based. In general, not just for flexible or elastic, but with all of them, people have success with everything from like a super glue to a really strong two-part epoxy. If it's not alcohol-based, it'll generally stick. So let's take a look at Preform, and we'll look at some of the stuff I have on the table here, if you can see it. This goes back to Dan's warning that you're going to want to zoom in. Let me just get Preform up here. Great, and hopefully everyone can see this now. And so what I've got here are a few parts that I think are nice because they're cool parts, they're interesting parts. Each of them sort of represents a different challenge in printing. but also they can show us some interesting things about best practices and about trouble you might run into while you're printing. So let's start with talking about this tire. And I have it leaning around this right here on the table. You can see nice flexible material. Feels very similar in hardness to like a car tire or something like that. But you might look at this and go, okay, it's full of holes and you've got these gaps at the bottom here. And people more experienced with printing on our machine might know why that is or might be able to puzzle it out. But these are pretty critical for dealing with cupping. And so cupping is this phenomenon, right, where if I have a part like this straight to the build platform and it's sitting here like this, and we have, this flexible film printing process where we have, or even on the Form 2, a hard bottom tank, right? We're curing this layer first, this top layer, and that's curing inverted against the bottom of the tank. When it comes time to peel, and you have that process of removing the part from the bottom of the tank to reintroduce resin underneath, you're essentially pulling away. And if you have a trapped air pocket with no vents, you end up with a suction. Basically, it's just like a suction cup, and that pulls. Something has to give before that's going to release. And the thing that should give and most often gives is the seal between the bottom of the tank and the part. If it's a really big cup, so right, if the internal volume is huge and the walls are thin and it's a delicate part, what might give is the resin itself. And this is the reason I bring this up. It seems like a pretty elementary thing. Is a lot of people with the introduction of the Form 3 have gotten kind of lazy about cups. And I'm talking about myself, really, as well as a lot of people I work with, as well as a lot of customers that I talk to. Because with that flexible bottom, right, it's not like you're pulling against a hard surface anymore. You have this sort of gradual peel from the edges in, where a little bit of it's not force on the entire bottom of the part at the same time. It's sort of gradual, and you can peel those edges away, and it's a lot more delicate with parts. And with hard resins, it's not a big deal. I've seen people print huge, full platform, full volume vases with no vent holes or anything. I did this at a trade show once, actually. And it's impressive, right? Because with this technology, now you can easily sort of release those cups. It's not a big deal. The parts are generally strong enough to take it, and the forces are generally so much reduced over the Form 2. Doesn't cause a problem, doesn't cause blowouts, anything like that. With elastic materials, with flexible materials, with any soft material, it's more of an issue because it's so much more compliant in that green state. Is so much more compliant while you're printing. And so, there's a very real chance that you can pull it, in that direction. The whole thing's going to move. And this is a theme we'll come back to when we talk about how to place supports and how to orient parts. You can see, I've got supports here, but they are very much, just as compliant as the rest of the material. And so the challenge always when printing something like this, right, is how do I make sure that my supports, which, on elastic, they're even softer, are very compliant. How are they going to hold the part in place, and how are they going to constrain it? Because it's not just about suspending it, right? It's also about constraining the part under force. We'll come back to that. But talking about the tire itself, it was actually funny when the marketing photos, and you might recognize this from some of our marketing around the launch, came out. Someone saw someone squishing it, and they see this little vent down here. And one of the sales reps messaged me, and he goes, "Is that a tear? Is there a tear in that marketing thing?" And no, it's not a tear. It's a vent. It's an intentional feature to relieve that cup. And there are lots of ways to do it. We probably didn't need 4 of these, but that just evens it out. And so, I think this is one of the first sort of lessons to think about while printing with a soft material is, there's always some force involved in printing. There's always some force being exerted on the part at some portion of the step, or in some step during the printing. And so how do we control where it's going to go? How do we relieve pressure anywhere we can? How do we avoid cups? And so you can see that same sort of principle applied with this other part. And you might recognize this as the elastic standard sample. You can request one of these right now if you really want one. It's a cool sample. I like having them around. Always gets a good reaction because it's a cool thing to see printed without supports. But if you've ever seen one, you might notice we've got these vent holes around the bottom. The whole thing is hollow. Needed to vent that cup. Same thing. But I put this on here not because I wanted to talk about cups, but because I wanted to talk about parts like this with a lot of fragile, delicate features coming off of it. And you look at this and you think, okay, I know flexible or elastic, these are soft materials. You know, we might be in trouble if we have a lot of dramatic overhangs with really fragile parts. Those might move around. You might get layer shift, something like that. Not really a problem when you design your part around it. And so you look at this, and our sample team's pretty clever with it. A lot of these parts are designed to show you that you can get these complex features without any supports, as long as you're conscious of what angles you're putting them at and their sort of position relative to the build platform. So anytime I'm setting up a part, I always like to slice up through it. I feel like in a lot of our tutorials and things like that, there's always sort of a throwaway line about how this slicing tool in the sidebar is really valuable and super useful and should always be a part of setting up a part. And then a lot of people ignore it. And I was guilty of this my first few months at Formlabs. And I've seen many customers who I say, well, did you slice up through the part? And they go, no, I never do that. And it's not because you can't get good results without it. These people aren't dumb. They're getting good prints. But it makes life so much easier if you start to think of each layer as a snapshot in time of your part, right? So at layer 175, this is what my build looks like. This is a real representation of my build. This is not sort of hypothetical. This is not anything like that. There is a moment in time, there was a moment in time during this print where we were at layer 175. We were at this point and we had these supports that weren't really connected to anything. We were this far in the process of printing this. And so slicing up through it, anytime I'm doing that, I'm always looking for overhangs that are coming out of nowhere and making a really fragile surface. And you can see this is an intelligently designed part, right? Because every time we go up through these layers, you have these overhangs that look dramatic, but the actual angles that they begin at are mild enough, and they're all within sort of our design guides and the things that you can read on our website about this, that we don't need supports here. And yeah, they're fragile, and yeah, they're poking off, but they're all moving upward relative to the build platform. And they're all sort of at this vertical enough angle that really, and all the peel force on a Form 3 is straight up and down. Really, you're not going to run into trouble. Where you would run into trouble, and this is an extreme case, you would never print this whole model like this, but there are sometimes you have a model with features going all sorts of different directions. I'll occasionally work with someone who's modeling for art or for entertainment, and they're making, the one I always, that sort of makes me groan when I have to set it up is, we have a lot of people who do like board games and miniatures for board games, and they'll design these wolves or other furry animals with lots of sharp tufts of fur going in every direction. And you look at that and you go, okay, there's no situation where we don't have, a bunch of these sort of points off in space facing down. And these are all unsupported minima, right? They all come out of nowhere. And they're all really hard to anchor. When we think about supporting a part, you want to anchor it to the build platform, right? And you want to constrain it and keep those things from moving. If I have one support coming up here, and trussing can solve a lot of this, right? So the way supports truss together and form these bridges for stability. If I have one support though coming up to support one of these points, how stable do you think a single strand of a flexible resin like this is going to be under force? There's a good chance it might tear away. There's a good chance for a lot of that sort of trouble to emerge. Or even if it doesn't tear away, right, it's going to sort of be sitting there flapping in the wind, so to speak, and you might run into trouble. So being mindful of features like this and going, okay, can I design conceivably a model like this where all of my features are going in the same direction and I don't have these dramatic overhangs? That's a major thing. The other thing specifically with soft materials is some of our engineers like to call it a wishbone. I'm not actually sure what the official terminology in our documentation is. They might call it an upside down Y or something like this, but internally we always call it a wishbone. And what I'm talking about is, I'll turn off minima for this, an intersection like this, where you have two minima coming out of, basically coming out of nowhere, anchored by support, and they come up and join in the center here. so this or this, or anywhere these branches intersect from this tree, if we're printing in this orientation, this is a really difficult geometry to print in a soft material, even if they're much larger than this, right? If you think about like our I don't know if you guys have seen our COVID response coverage lately, where we were talking about ventilator splitters, and we worked with a professor, I believe at UMaine, to work on ventilator splitters, which it's basically a Y-shaped tube, or a tube with multiple junctions. If you were doing that in a soft material, and there's no reason why you would, you're going to run into trouble where those two arms of the Y meet. Because of the sort of peel forces involved and the softness of the material, and these sort of very far apart anchor points, you might have a tear there, just like breaking a wishbone at a Thanksgiving turkey. So you always want to avoid geometries like this. Preform won't explicitly tell you, hey, you're using a soft material. You have a junction that looks kind of like a wishbone. Don't do that. But you very much should be mindful of that. I'm not saying it's impossible, not saying it's going to lead to a failure every time, but it is a significant thing, and it's a significant difference from our other harder materials. So I want to talk about actually working on a part that requires supports, and the differences between supports on this material and Flex V2, as well as sort of some of my philosophy around supporting these parts. But first, Dan, do we have anything in the chat regarding these two parts that we should be chatting about?
Let me unmute. Sorry. We've actually got a question about supports, which might help to just preload your next segment here.
Sure.
Tim asks, my biggest issue with printing flexible was that the supports would clump up and create masses on the part that were impossible to separate from the part itself. Can you talk about supports and how best to generate them so this doesn't happen, and then how to remove them cleanly?
Dan, did you plant Tim in the audience to sort of throw out one of these questions that leads right into what we're going to talk about?
I didn't, but thank you, Tim, for that prescient question.
That's a perfect question, and it's, I work for Formlabs, but I'm a user too, right? I do a lot of printing, both for customers and for myself. 3D printing's always been something I've done, and Flex V2 is that was a major frustration of mine with the old Flexible. It's challenging to deal with the size of the supports that we needed to get a successful print. And when you have supports in close proximity to each other, which you often needed with Flex V2 because it was sort of less stable, you'd pull them off if you could, and you'd get a big crater, or you would try to cut them off, and it was sort of a lot of material to move. So let's talk about supports now. And this part, to give it a real quick introduction before I get back to your question, Tim, is you might recognize it. It's the handle to the sort of now famous OXO fruit vegetable peeler, with these sort of soft, grippy fins on the sides. There's a cool story behind this part. I'll tell it in a minute, but we have a great partnership with OXO. This is a part they supplied to us for a lot of interesting sort of marketing. They do their prototyping with our flexible materials and a variety of others. I always love to talk about this part. I'll tell the story in a minute, but let's talk about supports first. So this is a part I set up just a couple days before in sort of preparation for this, so that we would have a look at one that I supported myself. And what I did here is I used standard size touch points. Normally I will go down from whatever the recommendation Preform gives. For a lot of the harder materials, I'll go down to 0.3, 0.25, pretty small ones. The old Flex V2 touch points for the material, I think, were 0.8, 0.9. They were pretty serious. We've gone down to 0.6 as a standard. I'm confident you could go even lower than this if you wanted to for some features. I kept it at 0.6 just so you guys could get an idea of what the new default is, but it's a lot smaller. And that's a function of a couple things. One is obviously the low force technology in the Form 3. You need less constraint on the part to overcome the forces of peeling, because the peeling forces have been reduced so dramatically. The other thing is just sort of a chemistry change for the material. It's much stronger in its green state. It's much stronger in its cured state. It's much harder to damage by flexing or pulling on. It's really a much more forgiving material to print with, which is why I have it so vertical. This orientation would sort of scare me in Flex V2, but we'll get to that. So First thing is touch points are a lot smaller, right? So that solves a lot of that problem off the bat where it's hard to remove supports or they leave pock marks or they cause problems. As supports get smaller, everything gets easier because the strength of your hands doesn't change. And the sort of fundamental laws of the tensile strength of the material and the shear strength, all of that don't change. So the smaller the touch point, the easier it is to pull off. The other thing is you'll notice, we'll go into support edit mode just so you can see where I've placed it. This is probably over supported. I did it because wanted to, I didn't want to come out here and be like, oh, I work at Formlabs, I do this every day. I've got a really aggressive support, setup that is going to take you 4 failures to duplicate. I want to give you a realistic look at a part. So this is probably over supported from what I would normally do. But you can see none of these are packed that tightly. And part of that's because, when the touch points are bigger, they start to meld together. You end up with those sort of unsightly clumps. But also, you don't need to pack them that tightly. Sometimes the software will pack it really tightly because it wants to make sure that you get a successful print the first time. You don't waste any resin. Maybe there's a little more handwork involved. But all I did here, and let me duplicate this and we'll sort of do part of it together live.
Josh, I'll just ask, when you're editing supports like this, would you recommend to most people to start with the auto-generated and then remove supports, or build up from none manually?
Yeah, I think it depends on the part, right? So for a part like this, I generally, I guess it depends on how much time you have. That's the other sort of factor in that equation. For a part like this, I don't bother auto-generating it and removing it because I'm looking at this, there's not actually that much mass I need to support. And so in my head, I've sort of done the, I have a gut feeling of, okay, I'm going to need about this many supports. I don't mind placing them. I can place them pretty quick. For something huge and blocky, for something that I know is going to involve hundreds of supports because it's a 4-inch cube or something like that, I go auto and then I remove the ones I don't want. The trick with going auto and then removing them is sort of a function of how the software thinks, right? So the software doesn't, you as a human being can only place one support at a time, right? You look at a model and you place a support and then you think about how that's impacted the model and you place another support and you keep going like that and you sort of work your way up, or at least I do. I work my way up right from the base, that anchoring point of the model, all the way up to the top, and I sort of think through it and I place supports relative to each other after they've already sort of had their influence on the part. The machine looks at the part and it's a lot smarter than you or I, and it can place all its supports at one time. And it decides where they're all going to go relative to each other. And the density tool is sort of how you control that spacing, right? So the location of the supports is not necessarily based on what's best, and it's certainly not based on what's best for a version of it where you remove half those supports or a third of those supports. It's based on the proximity to all the supports that the machine knows in that moment it's going to place next to it. So it will do some things which make a lot of sense in the context of all the other supports it wants to place, but that don't necessarily make sense in the context of having a lot of those removed. And you end up with some things that you look at the program and you go, geez, why did Preform do that? Preform sucks. Preform doesn't suck. It's just sort of operating on all the variables at the same time. So there are pros and cons to each. That was sort of a long-winded question, or a long-winded answer to your question, Dan. But that's how I always think about it is, is this reasonable for me to do myself? Or do I need the help of the machine? And if I do need the help of the machine, I'm going to need to bear in mind that sometimes it's placing things that make sense in the context, in the sort of holistic context of a fully supported part, but don't make sense to me as I'm removing them. So the way I would normally go about supporting this part is I would look at it and I would think about a couple of things. One is, let's talk about orientation first. So one is orientation relative to the build. The more vertical it is, right, the more I'm going to get that cross-section I'm looking for when I scan up through it. So, I'm scanning up and every one of these layers looks exactly the same as the last one. And that's great because there are no overhangs that I'm worried about are going to, possibly fail or be too weak at a moment in time. But a vertical orientation, while it's great for hard materials, is rough for soft materials because the more vertical it is, the more distance you have vertically that can let it sway sort of under force, the more opportunity there is for a layer shift because it's a soft material. and the smaller the base or anchor point of supports that you can put on it. So I always like to think when I'm supporting a part in terms of a tripod, because a tripod is a really stable structure to hold something up, right? And so when I'm orienting, I like to think of, okay, where are the legs of my tripod going to be so that the whole part is relatively stable and hard to shake, while it's printing. And you can see I've sort of done this here. This is the lowest point on this orientation I've chosen, and then I have sort of a raft which comes and forms two legs at either end up here. And so, and I have good support throughout the entire length of the part. This is a pretty vertical orientation I chose over here for a soft material. A lot of our support documentation and a lot of contemporary wisdom about this is to keep it as low and flat as possible, right? Because if I come down at an angle like this, suddenly I have a ton of space to anchor supports to the platform. I'm gonna have really good adherence. I'm gonna have a really stable structure. My sort of tripod base has gotten a lot wider, and so it's a lot more stable. That's awesome, but there are trade-offs there, right? Everything's trade-offs. People think they can 3D print, and it's like making something for nothing. It's like alchemy, but you don't get anything for free in this world. And so when we go really flat like this, remember these layers are a snapshot in time. This part exists at layer 62 looking like this. You end up with really fragile features that can easily have problems during printing. So like, look at that. Do we like this? That's 100 microns tall and probably only a little bit wider. Do we feel comfortable that at layer 56, when the printer peels, it's not going to pull this up and cause a separation here or cause a layer shift or cause something else to happen? I don't personally feel confident. And what the machine will do to overcome this is put a lot of supports clustered up in this area. And this goes back to the question we were talking about a minute ago. How do you prevent clusters of supports? When it's clustering supports, it's because it knows a feature is going to be weak while that feature is trying to be resolved during printing. And so if we have weak features like this, where we come really flat to the build platform, and we could go even flatter than this and see it more dramatically, the software will know, let's cluster supports here, because this is not going to survive on its own. This is not a stable bridge between supports if we put one here and one there. So for elastic, for old flexible, I might go fairly flat. I might compromise around here. With this material, it's actually pretty stiff while printing. I was shocked the first time I printed with it, honestly. And so I felt more comfortable going up at a vertical angle like this. This part is also pretty forgiving. To be fair, these walls are fairly thick. It's pretty chunky. It's nicely vented. It's not going to be a big issue. So what I would do once I had my orientation, we'll go with this, it's close enough to the other one, is I always like to snap to the bottom. And again, look at this sort of footprint that I have and think, okay, where's the lowest point? And we can do this by turning on show minima, if it cooperates with me. We can also do it by just slicing up through and looking at the first few layers. And so I think, okay, that's the center point. That's the point where it's going to originate. Let's go into support edit mode. And this may take a sec. I'm doing this on a little Mac laptop. Usually I would do this on a desktop, but it doesn't really work well on camera to have two big monitors between you and me. Is this going to cooperate with me? Guess not. We're going to go over to this one. We'll look, right, so there's my lowest point, and it's going to slice up the opposite way when we're in support edit mode, which is also a really handy tool that I think people don't know about is, right, it inverts this slicing. And I think, okay, I want a few nice strong anchor points there, and then I want to build a base for support. And the reason I've got so many supports on this underside is their sort of influence, their ability to anchor the part is going to influence the entire rest of the part. So if I have a strong base here that doesn't allow this to shift at all, I'm going to need fewer supports up here just because I'm building on a good foundation. If you start with a really thin, broad layer that's likely to warp due to force, or a really poorly supported layer that might tear off in points, you're probably not going to have a failed print. The Form 3 is pretty good with recovering from issues like that, partial delaminations, supports disconnecting. I've had very few actual failures on a Form 3, which is surprising because I print a lot and I do a lot of risky orientations. What you will have is a part that's not quite right? It's like building a house on a foundation that isn't level and square. So I really always want to anchor this bottom part so that my life doesn't get hard throughout the rest of the part. And from there, that's honestly most of the work. You can see these are pretty sparse compared to down here. I just track up, I think of a leading edge, right, that I want to have my supports run up, and I just track up them, giving them plenty of space before coming to the top. And you can see none of them are clustered that badly. The bottom isn't, destroyed by all this sort of clumpiness. I have another one of these that I can sort of show you the bottom of here. And the supports will just tear off. These are a little bit larger than I would like. But you can get a fairly smooth round bottom just like that. And so that's my general approach to supporting these softer materials. If it's fragile, if it's big, or if I'm going with something like elastic, keep it fairly flat. Flexible, you can go a little bit more vertical, make your life a little bit easier. But if you go too far straight up and down, you're going to have trouble getting enough of these supports, right? Imagine if we were going totally straight up and down and we only had that little cluster of supports at the bottom of the part right there. You want to have enough trussing and enough support between supports to keep it standing, but the more vertical you can go, the easier it'll be. Dan, we got questions. Does that make sense to everyone?
Yeah, I think so. So Tim asked a follow-up. He asked, is this material only for the Form 3? If it can be printed on the Form 2, which is the one we have, can we not use 0.6 for touch point support size? So yeah, the touch point support size is, if it runs on the Form 2, you can set it to whatever thickness you want. I believe, Josh, and you probably know better than me, these new soft materials are on Form 3 only.
I believe this material is also on the Form 2.
Okay, great.
I'm certain this is available on the Form 2 as well.
Cool.
We are still supporting the Form 2. Some people got nervous. We are not, dropping all consumable support. We are not being super limited in terms of materials for the Form 2. If we can physically get the material to run on the Form 2, we're offering it. It might be a little bit different of an experience. You might need larger touch points to keep it anchored, but generally this material is such an improvement over Flex V2, to be totally honest with you. You are going to get a better result on your Form 2 than the older material, and I would say it's worth a shot. I think you could probably still try to use those 0.6 touch points. Obviously, there's more force and there's more lateral force involved on a Form 2. The peel process on a Form 3, it's both gentle, but it's also totally vertical, which is great for soft materials because the big issue with a soft material is if you have this shearing force like the Form 2 does, where you peel by quickly moving that build platform to the side and pulling the material with it until it breaks off. That's going to be the bigger challenge, and the thing that's going to limit your geometry is that peel on the Form 2. If you're doing something that you've designed intelligently, supported intelligently, I would have no concerns about this material on a Form 2. Come to think of it, I've seen prints off of Form 2 when they were doing original testing, the unfinal version of this material. It works fine. It's just sort of the same difference between a Form 2 and a Form 3 that you think of with our other materials, magnified up a little bit because they're softer and peel force matters more.
Right. We've got another question here more generally about Preform, which I'm trying to remember. I might not have the answer to this off the dome, but does the Form 3 still suffer from Z compression like the Form 2 did when printing directly on the build platform? I believe it does, but you may also have a better sense on that one than me, Josh.
That's a great question. The answer is no with an asterisk. And what I mean by that is, with the Form 2, the way we would get it to adhere to the platform is through that compression, right, as you say. So we would sort of shove the build platform into the bottom of, at that point it was a hard tank, right? You have that layer of plexiglass, with a softer material poured over it. and we would compress it that way. We don't do that on the Form 3 because of the flexible tank. You can't really compress it like that. You can't shove it into the bottom of the tank. If you somehow hacked your Form 3 and because you really wanted to compress your material and you told it, hey, slam that build platform really hard into the bottom of the tank, you'd probably dent the tank. You wouldn't tear the film, but it's not good for the life of the tank. So we moved to an approach of changing that first few layers adherence to entirely rely on different patterns of curing and laser intensity. And so those first few layers, the laser intensity, the scan speed, the pattern it scans, and it's different. And the goal there is to just adhere it through slight over curing, essentially. So you will not see that dimensional change in the z-axis that you would on a Form 2, where parts would get shorter because they were being compressed. Parts should come out pretty much true to size in the z-axis.
But you still may get a little weirdness right at the top because of the laser behavior just being different than the rest of the part.
Right. It's going to be a lot more minor, and if you're going to see any dimensional inaccuracy, it's probably more likely to be too long rather than too short, by a much smaller factor than it would be on the Form 2.
Cool. I think that's it for non-post-processing stuff, so feel free to move on.
Cool. I want to derail this a little bit to talk about the OXO peeler and sort of uses for this material. So we throw a lot of applications out. We love to throw applications out when we're talking about new materials, things that you have access to on your machine, what you can do with it. This is a great material for making these sorts of overmolds. And this part in particular, I think, is a really cool representation of the elements that have gone into the Formlabs ethos years and years later. And what I mean by that is, I don't know if you know the story about this part. You can see it all over the place. The place I first read it was in Donald Norman's Design of Everyday Things, which is a great book. Highly recommended if you want to think about design. If you ever went through design school or something like that, you probably read it, or you were probably assigned it, and maybe you read it back in school. And what's cool about this is the designer of this grip was sort of a serial designer of products. He had a variety of innovations that he would try to sell to companies. And he sort of hit a dry spell where he didn't have a new product. He took a vacation with his wife, I want to say to France. I don't remember the details that well. And she had arthritis in her hands. And if you remember, the sort of old school vegetable fruit peelers are these sort of horrible looking bent pieces of metal, right? They're really small. You sort of have to stick your thumb on the blade to keep it where you want it. They're hard to use, especially, I would imagine, if your hands are arthritic. She essentially said to him, hey, can you do something about this? Can you design something better than that? And that spurred him to designing a more accessible vegetable fruit peeler, right? And designed for accessibility, designed for everyone, wasn't really so much of a thing in those days. It wasn't really a thought of, how do we take this tool, and you see where I'm going with this if you follow a lot of Formlabs marketing, how do we take this tool that we've identified there's a group of people it's inaccessible to, or at least it's difficult for, and make it easier to use, more comfortable, rethink sort of, everyone's been making them the same for a long time. How do we rethink that? And how do we make it, possible for other people to use? And so they came up with this, which is, right, you probably have one in your kitchen, or you've seen one in the kitchen at some point, this overmolded rubber handle. And rubber wasn't really being used in kitchen appliance or kitchen hand tools at the time. There weren't really any rubber things in the kitchen in these days. And so it was using a sort of radically different material, and they went through a ton of prototypes, having to sort of painstakingly figure out what shape works, how it works in the hand. They wanted people to really grip it correctly with these ribs, so they added them. You can go online, you can find photos of the prototypes. They did all sorts of different ribbed versions. And they sort of got to this final product, which is now ubiquitous, not because everyone's got arthritis in their hands, but because through that design process and through using radical materials and prototyping over and over again, they created something which was more accessible and better for everyone. And so, when we talk about the Formlabs mission statement, and this is sort of, the shameless marketing plug. I'm on sales, but we can do it too. For the Formlabs mission statement, we want anyone to be able to make anything. This is a great example of that, right? Where it's iterative prototyping, it's using radical materials, it's designing an overmold, which is sort of part of our topic for today. But it's also, thinking about interesting new ways to do things that people haven't done before, and using sort of power of prototyping and human-centered design to achieve those goals. And so I love bringing this part into any talk I give like this, or any trade show I show up to, because it's a great story that it's a super recognizable part, right? And the fact that we can simulate it and print one off in a few hours, and replicate a material that is extremely costly to tool up for. That was the big limitation for them. That's an exciting part of the story. But the other exciting part of the story, right, is the good that 3D printing, the good that people can do when they design, and the good that 3D printing has the potential to bring to that design process, and enable more people to design things like that based on the need they see in the real world. So hopefully you'll excuse the tangent, but I like to sort of go into that story anytime this part is around, because I think it's a great sort of summary of what you can do with technology for rapid prototyping, but also of sort of our mission at Formlabs. Want to talk a little bit about support removal now? How'd you like that abrupt segue? Talk about post-processing and the differences there. I know we sort of touched on it already, but these supports are a lot easier to tear off. We throw around light touch supports, soft touch supports, all that sort of stuff. It is very much true. And
Josh, do you want to stop sharing just so we can get a slightly bigger view of you, if that's okay?
That's a great idea, Dan. This is why you're the expert and I'm the guest speaker. How's that?
Perfect.
These are easier to pull off. Whether you want to pull them off is another question. In a lot of cases, you can do it without much trouble, but I'm a big proponent of two tools for this. One is the obvious one, comes in your finish kit, flush cutters. That makes life a lot easier when you're working with things like this, because one of the big complaints, one of the big concerns that we've sort of overcome, but not fully, with soft materials is when you yank one of those supports off, is it going to pull away cleanly at the surface of the material? Is it going to pull away part of the part itself? Or is it going to break somewhere along the stock? And in the case where it pulls away part of the part itself, it's really hard to fill those craters. So anywhere I'm concerned about that, or anywhere I think that I'm going to be pulling so hard it's going to cause that problem, I like to go in with flush cutters and cut a little bit. I should have done a hand cam for this. Sorry, Dan. Cut a little bit farther up that stock away from the part, or as close as I can get, just making sure I'm leaving positive nubs on there. It's a technical term, positive nubs. Tying this to another one of our materials that you may or may not use, we actually came out with some really cool supports for castable wax not long ago, which are actually designed to never break away cleanly at the surface of the part. It sounds stupid, right? They break further down the body of the support so that you always have a positive entity that you can then remove, because it's a lot easier to remove more material than it is to fill it in. And removing that sort of positive component of it, I like to use an X-Acto knife. Again, seems obvious, but a lot of people don't use them for this for whatever reason. And you can really easily, this material is still hard enough that you can easily sort of shave that away and do really nice, precise work, just sort of taking them down to the surface of the part. So you can rip them. It's a lot easier to rip them with this new material, with these new settings. But if you want a perfect part and you want to minimize the amount of sanding you're going to have to do, or God forbid, trying to fill it with something, flush cutters followed by the X-Acto is the best way to do it. Some people still do want to sand it. They find that's a lot easier than trying to clean up those points individually with an X-Acto or something like that, and they want to get a totally uniform finish. You can sand this material. It becomes easier if it gets colder, right? All of our materials, and this is, because they're photopolymers, all of our materials get stiffer and more brittle when you heat them way up or when you cool them way down. So, a common thing for people to do is, take something like this, throw it in the freezer, take it out, then hit it with a sandpaper while it's still a lot firmer. But you can sand flexible. You can sand flexible V2. It's a little trickier with elastic unless you've got it really frozen just because it's so soft, as you'd expect. But sanding is absolutely a recommended, reasonable part of the workflow. The other thing I want to mention when we talk about post-processing is color. So you can see we've gone to this sort of clear, translucent color for flexible. This is actually what Flex V1 looked like, I believe, before we went to that dark sort of charcoal color. The reason we did that is for a variety of reasons. One is an increasing interest from medical customers who want to make surgical trainers, want things like that, want to be able to see fluids flow through it. But the other bigger one is it's a lot easier to add pigment to something than remove pigment, right? So Flex V2 was always going to be that dark color. Wasn't a lot you could do about it. You could paint it, but this, all sorts of things you can do to color it. Some people experiment with putting dyes in our resin before printing. It's doable. I've seen people do it a ton of times with elastic, especially for those medical models, medical trainers. They'll try to make it look skin tone, flesh tone, something like that. The thing you have to consider there is adding pigment always, will scatter light, will diffuse light. It will make it cure differently. You might not get exactly the properties. So if you can add a little bit just to get a tinge, you'll have much better success. You can also dye it after the fact. You can use things like RIT, R-I-T, fabric dye, which is also designed for polymers, so synthetic fabrics. Drop it in, put the dye in. Basically, it's a dye water mix. You drop it in, you boil it. That color will sort of soak into the top layers of it. One of our material product managers, Kathy, who you may have seen give a couple presentations recently, also did a lot of painting on this material before we released it because she wanted to see how it would show up. And she found for things like this, where you have sort of an inside area and you have sort of a cavity that you can reach, painting the inside of it, the color will actually show through and it looks really nice. And it's a more durable finish because it's not actually on the exterior, you're just getting that color shining through it. But it's paintable like all of our resins. Again, no alcohol-based paints, but a variety of others will work. There are lots of ways to color this material. We wanted to make it easy to color, but also easy to have translucent, transparent if needed. That's really all I wanted to cover. I think we're running up near the end of our time, but absolutely want to make sure I get to any other questions that are at play here.
Yeah, thank you, Josh. That was terrific. Really appreciate it. We've got a couple questions, and we'll get through them because I think some of them are really important. I've seen a couple times folks have asked, but I see Gustavo here in the Q&A. Are these materials skin safe? Can they be used for a wearable?
Sure. So we would never advertise these materials as skin safe, and the reason for that is we haven't done that testing. We haven't pursued those certifications. We have a couple materials that are skin safe, but they're obviously much harder than this. What I'll say on the topic of wearables is touching this, holding it in your hand, it's not likely to cause an issue. The liquid resin is an irritant, but once it's cured, it's very stable, it's very safe. I have plenty of customers who do use it for prototyping wearables. I've seen watch straps made. I've seen a variety of other things that were designed to go next to the skin, but they do it at their risk. We haven't pursued any sort of thing that would make it medically certified as suitable for being skin safe. It's sort of, at your discretion, at your understanding of your process. What I'll say is if you want to make sure 100% that it is skin safe or that it's safe to have in contact, we have a great blog article that is sort of like an ultimate guide to coatings and, all that sort of stuff, skin safe coatings for it. There are a variety of coatings that you can spray onto a material or dip it in or whatever. And a coating will always be a nice, known quantity if you can find one that fits your workflow in terms of your requirements for skin safety.
I just threw a link to that guide to food safety into the chat for anyone who's
curious. So fast
on it. We've got two kind of related questions, which I have another link for that I'll post. But Slade and Rob asked, have you done accelerated aging tests? What can we expect over time? And Slade asked, how about other material properties, durability, elongation, etc.? We have technical and material data sheets for every one of our materials. If we test for something, it's going to be in there. if we don't test for something, it won't be in there. So Josh, have we done, the only one I don't know is kind of aging or long-term tests. I assume because these are pretty new materials, we don't have months or years of data on that stuff.
Yeah, that's a good question. In terms of accelerating sort of aging and ambient conditions, right? Sitting, in UV light, in wind and weather, whatever it is, hot, cold. We generally don't do much like that for our materials. It's a hard thing to simulate, and especially since it's so application specific. In terms of long-term wear and fatigue, we have done some testing on, repeated cycles, flexing. I believe that's on the product page. I could be wrong there, but we had some numbers that we were throwing out in terms of, number of times you can flex it before you start to see any damage. And we were using that as sort of a benchmark to test against Flex V2 to make sure that it truly was as durable as we wanted it to be.
Got it. And then I also, in our chat, just posted, we have a technical and material data sheets for every one of our materials, like I just mentioned. If you go to the last link I just posted and scroll all the way down to the very bottom of that page, you'll see 2 drop-down menus where you can select the type of material you're looking for, and that'll drop the, it'll show you the material or technical data sheets for those materials. All right, Josh, I think we got time for one more, but I think this is a really good one. Katrina asks, my elastic parts always seem to come out sticky, even with fresh IPA. Do you have any tips for mitigating this?
You're giving me one of the tricky ones for last.
Oh, so
no, that's fine. Anytime someone tells me they get parts that are ending up sticky, even with fresh IPA, my first question, and this is not me sort of trying to, always push the Formlabs product. My first question is always, are you using a foam wash? And you might be, and we can talk. I'll get into that if that's still the case. But there are a lot of people who do it just with a finish kit. I have a finish kit here because I'm working from home due to this whole world phenomenon that we're in right now. I have a finish kit here because I'm limited on how much alcohol I want to store. I didn't want to make the company ship me a whole bunch of hardware. I don't want to have to drag it back once we do go back to the office. So I've got a finish kit here. And yeah, it is a lot more of a challenge. It is a big pain to try to get, a lot of the materials, a lot of the time with elastic even, it's not so much of a problem, but there are some that I feel you, it just won't stop being sticky in the finish kit. And my solution there is always to sort of positively run IPA over the surface of the part, either safely with a squeeze bottle back into the finish kit, with a syringe if it's small channels. I find, not just relying on agitation or the impeller the impeller in the bottom of the wash or the agitator basket in the finish kit. If that's not enough, some sort of positive flow of IPA really sort of spraying down the part in a safe way. Obviously, it's flammable. Makes my life a lot easier. So I will generally take a squeeze bottle, fill it with IPA, and in a safe, well-ventilated space, into the finish kit, sort of blast it down with IPA. I think the stickiness is sort of just a function of it's a pretty viscous material that sort of, the liquid material sort of hangs around the part and it's hard to wash off. That sort of more aggressive washing always solves it for me.
Yeah, and someone just posted in chat. They said I've done a pre-wash with IPA before going through the form wash, and that helps. So that's a great tip from another user.
Also a great tip.
Awesome. Well, Josh, thank you so much for your time. This was great. We got some really terrific questions. Like I just said before, everyone, if we didn't get to your question, I apologize. We ran out of time. You'll see in the chat, I posted the link to our forums again. Please hop in. I saw some folks asking about specific paints that work best on these materials. That's a terrific question for our community. I'm sure people have great tips for you. Also, if it ends up on the forums, I can jump in and ask around the office here as well for recommendations. So feel free to come join us there. We'd love to hear from you. But yeah, I think that's it on our end. Josh, anything else to add?
Nope, I think that's all from me.
Awesome.
Thanks,
well, thank you, everyone. Have a safe and lovely rest of your week, and we'll see you next time.